Hello students, welcome to this first lecture in the structure of the atom. The structure of the atom chapter is very much crucial for your examination purpose or as well as your knowledge purpose. In this chapter we will learn different things. First we will learn that the discovery of the subatomic particles. Then we will learn about the different models, that is J.J. Thomson atomic model. Then we will learn the Rutherford atomic model. Afterwards we will understand what is atomic number, what is the mass number. We will also understand the nature of the electromagnetic radiation and how Bohr has improved the Rutherford version of atomic model, in which way that he has made such a progress, that we will discuss in these different videos. And nature of the matter, the de Broglie's equation, that we will discuss. Heisenberg's uncertain principle, that we will discuss, and afterwards that we will the most modified version, the quantum mechanical approach towards the atomic structure. So all those things we will discuss in different videos. In this video we are going to discuss the discovery of the subatomic particles, that is the most important subatomic particles is your electron. So have that today's video, this is discovery of subatomic particle, discovery of In this video, we are going to discuss the electrons. How the electrons has been discovered by scientists. Electrons means the discovery of the electron. As per Dalton atomic theory, Dalton has given the atomic theory in the year of 1808, and he proposed the one vital thing, that matter is made up of the very minute particles. This is called the atoms, and this atom is undivisible and uncuttable. This is the fundamental element of fundamental particle of the matter. That is his main conclusion of his atomic theory. But in the end of the 19th century and the beginning of the 20th century, you will see there is a development, and scientists came to a fact that atom is divisible. Atom can be divided into subatomic particles, that is electron, photons and neutron. In this video we are going to discuss how the electron has been discovered. Electron has been discovered by a scientist, eminent scientist J.J. Thomson. J.J. Thomson in the year 1898, he discovered the electrons while he is making the experiment on the electric discharge through the gases. And for that electric discharge, for the experiment of the electric discharge through the gases, he has been awarded in the year 1906 the Nobel Prize. Now see how J.J. Thomson had discovered the electrons. While he is experimenting on the cathode ray discharge tube, the diagram of the cathode ray discharge tube is this. You can see it is basically a tube where the cathode and anode is seated. When we make the 10,000 potential difference, 10,000 very high potential difference between the cathode and anode, and there is a pressure in the gas inside the tube that we can able to regulate, we can able to control by using this evacuating tap. This is the arrangement. In this arrangement, you can able to evacuate the cathode discharge tube gas, and you can able to monitor, control the pressure in the inside the gas. So in this, when we keep this pressure, we keep the pressure around 10 to the power minus 2 atmosphere, very low pressure. What you observe? He observed there is a flow of electricity. Means it can be understood there is a glow in the cathode tube, and this color of the tube depend on the which type of gas you kept. Suppose you have kept is a hydrogen gas, then you will have the greenish effect. You keep the other gas, it will give the different color. So when this pressure is 10 to the minus 2 atmosphere, the low pressure, and at the potential difference between this cathode and anode is 10,000, he observed there is a flow of electricity. Now when this pressure is made 1 and 10 to the minus 4 atmosphere, the glow stops, but there is a electricity is going from this cathode to anode, and that can be perceived by the zinc sulfate coating at the back side of the anode. Here the zinc sulfate coating, ZNS coating, zinc sulfate coating inside behind the anode is given to understand whether there is any flow of electricity or not. And what he observed, zinc sulfate, there is a teeny flash of light, means there is something is coming from the cathode, and this is called the cathode ray. So we can write the cathode ray has been produced from the cathode to the anode when we use the pressure inside the gas is 10 to the minus 4 atmosphere and the potential difference between the electrode 10,000. So this is the cathode ray, and what is the characteristics of cathode ray that we can understand, which is very much necessary for us to understand the discovery of electrons. So we understand the cathode ray has been produced from cathode to anode. Cathode to anode. When we keep the pressure inside the gas is very low, that is 10 to the power minus 4 atmosphere, and the potential difference is 10,000. So what is the characteristics of this cathode ray? That we understand the cathode ray passing from the cathode to the anode, and it travels in a straight line. So we can write it travels in straight line. How we can say it travels in a straight line? Because if we put any object in the path of this cathode ray, what we will find, there is some image of this object, means it is moving in a straight line. Second point, if we put any soft paddle in the path of the cathode ray, what we find? We find the paddle is moving, means that cathode ray is made of some particle. So we can say cathode, we can say this ray means cathode ray. This cathode ray consists of particles. This cathode ray consists of particles because it has a momentum. When it has a momentum and we put some paddle, soft paddle, very light paddle, we find this is moving and this is moving. Means what? That is a consists of a particle. Third point, when we put a electric field in that cathode ray tube, what we find that cathode ray is deflect towards the positive plate of this electric field. This means this ray is negatively charged. This ray is negatively charged because it is attracted towards the positive plate of the electric field, negatively charged. So this is the basic three characteristics. Fourth point, it has the capability to penetrate a very small thin metal object. So capable, we can write capable of penetrating some object. Fourth point, it has the capability of ionization. It can ionize the gas. It can ionize the gas. Sixth point, it reacts or it affects the photographic plate. So it reacts the photographic plate. That is what we observe here. When you put the zinc coating, this is very photographic sensitivity, and this cathode ray make a very tiny glow here. There is a tiny glow here. Because of this, it has the capability on the influence the photographic plate. So these are all the 6 characteristics that you can see. It is a very important characteristic you must understand. So what is its characteristics? It is a particle and it has some negatively charged, and this is called the electron, and it has been observed it is independent of the gas in the cathode ray tube. It is independent of the electrode in the cathode ray tube, means it is a fundamental particle of the atom, means it is the electron and it is fundamental particle. Now we understand, we now calculate that what is the charge of this particle, what is the mass of the particle. Okay. The second thing that we have already understood, what is the characteristics of these subatomic particle electrons. Now we want to know what is this charge, because we understand from its behavior it is a charged particle. So what is the mass and what is the charge of this particle? So for that again J.J. Thomson come. J.J. Thomson come and he told that E by M ratio is 1.76 into 10 to the power minus 11 kg coulomb per kilo, where the unit of the mass is kilo and it is SI unit, and the charge unit of the charge of the electron is coulomb. So 1.76 into the 11 coulomb per kilo, that is a E by M ratio that he has been calculated on experimentation by seeing how much deflection is going on is there after making some arrangement by electric field and the magnetic field. There is a combination that you can or that you can able to understand from the NCERT books, that is written very clearly, that I am not going to go to the details of that. So this is the E by M ratio that is calculated by J.J. Thomson, and another scientist, Millikan, he gives the charge of the electron is 1.6 into 10 to the power minus 19. Now if we put this two value in the E by M, it is given by E by M, it is given by 1.76 in 10 to the power minus 11. So we are putting this value here, which will coming out 1.6 into 10 to the minus 19 by m, 1.76 into 10 to the power 11, and it will coming around 9.1, and you can calculate yourself, divided by minus 31 kilo. So we can understand, and if we take this relatively with respect to the mass of the hydrogen, we will found that it is 1 by 1837 of the mass of hydrogen atom. Mass of the hydrogen atom. So we can now understand what is the charge. Charge is what? The charge of the electron. Charge of electron is 1.6 into 10 to the power minus 19 coulomb. Mass of the electron is 9.1 into 10 to the power minus 31 kilo, and which is we can write, which is 1 by 1837 of the hydrogen atom mass. Hydrogen atom mass. Okay. So we can understand the electron, discovery of electron, and now the point is, how the electron has been generated. What is the source of the electron? Source of the electron is the cathode. Initially from the cathode there is a electron comes out, and after that what is going to happen? The gas inside the cathode tube is ionizes by the electron, and it will, all the electrons has been removed from the gas, and it will make a ray of electrons that is called the cathode ray. So that is all for today's video. In this video we have understood how the electron, the most important subatomic particle, has been discovered by J.J. Thomson. J.J. Thomson has been awarded for this in the year 1906. How is the charge of the electron and what is the mass of the electron, that we calculated from this ratio. First, J.J. Thomson has calculated the E by M ratio. Then Millikan, from the world of experiment, he came out with the charge of the electron, that is 1.6 10 to the minus 19 coulomb. This is coulomb, and when you put this value, you will get that 9.1 into 10 to the minus 31 kilo. That is the mass of the electron. And the mass of the electron, the one thing that my master will tell you, this is basically a stationary mass. When the electron is stationary, suppose I am here stationary, I have some mass. But if I will move some speed, does this mass of myself will be there? It will not be there. That the mass of the electron, suppose you have been told in the IIT JEE, this type of question sometimes arise to confuse what is the mass of the electron when they are in the motion, in the speed of v. Naturally, there is a lot of the student who do not have this knowledge. He would say, look, the mass will be 9.1 10 to the minus 31 kilo. But it is not like that. When the electron is moving, then their mass, and when electron is stationary, it will be defined. And you can calculate from this formula, when the speed of electron is v, and at that time its mass is suppose mv. So this can be calculated from this formula. Formula is this: mv is equal to m rest. When electron is taking rest, then it will have this 1 minus v by c the whole square. Here c is the speed of the light. C is speed of light. This is C is the speed of the light. So C is the speed of light. So when you put the C as V, then you will get it is a infinity. Means when the electron moves in the speed of the light, its mass will be infinity. So that is all today's video. Next video we will discuss the discovery of the protons and the neutrons. And till then, all the best and be best. And if you like this video, you can share to your friends. Thank you very much for watching.